So in this particular unit, when I look at computer systems and software, the first part of the learning outcome focused on understanding what is hardware and what constitutes that hardware when we talk about it in the sense of computer system. And the second learning outcome, we are going to understand the software or the applications which actually drive the hardware, and that is where the learning outcome 2 focuses on understanding the role of the computer, role of the operating system, role of the software applications that we install. Because if you buy a piece of hardware, you put together a PC, for example, you assemble it or you put it together, you create a PC, but at some stage, in order to drive those hardware components and to make it work, to give you some meaningful output, what you have to do is install software on it. And without software, you can't actually use the hardware. So some part of it can be done through Linux programming or Unix programming, but beyond that, at some stage you need some sort of a program. So even Linux and Unix, even though they are command prompt based, or do not have a graphical user interface, some of the options today from Linux and Unix also have GUI interfaces, graphic user interfaces, but still that software is required to drive the actual hardware, which is your processor, your memory, your motherboard, and basic components of the system. So in order for all that to work in unison as a particular system, which is basically a PC or a tablet, or in various forms that you see today, like a thin client, a server, you still need software to be able to drive that hardware. And that is what we're going to be looking at today in this learning outcome 2. So there are a few slides which have been put together, and they give you an idea in terms of understanding the various assessment criteria which are given here. We want to be able to look at different operating systems. We want to be able to look at how to understand how these different softwares can be made to produce a particular output. Like we are using PowerPoint as a software here, and that software allows us to make presentations, and the output of that is a professional outlook in terms of a presentation, slides that can be shared with users and learners. So we'll look at understanding a bit more into it, and I'll kind of go into some of the slides now. So let's look at the key term. Like we understood what is hardware, now let's understand the key term, what is software. Now, if I literally have to define it, it's a set of instructions which are put together by programmers or coders, which then allow the set of instructions to be executed in a particular fashion, and at the end of it delivers an output. So sometimes when you're on the DOS prompt, to give you an example, if I pull something out on the Mac, which is called the terminal, and if I want to see a directory structure, so if you are able to see this on my screen, if I just do directory structure ls, because Macs are Unix based, so the directory command for Windows-based systems is dir when you want to see the directory. But if I do ls and I do /p, or there are certain options which can be created which allow you to get the directory structure of a particular drive. So this is allowing me in the background a piece of code which has been written, which is designated as something called understanding the structure of a directory on a hard drive. And when I type that command, what tends to happen is it runs those instructions in the background, and then is able to provide me an output, which is what is displayed here in terms of the structure of the directory command. So if I have to put something which is to do with get into a directory, things like we have to do cd, and I want to go into Dropbox. So what I'll do is basically write that, and I'm going to go into Dropbox directly. Not too good with Linux, but sometimes when you look at running certain set of commands, they are instructions which primarily execute a program, or these set of instructions or codes which have been written, and they then produce a bit of an output, and that is called a software. So when we look at booting up a PC, another example that I would give you is when we boot a PC, what we do get to see, like I exit the console, it deletes the session, clears the memory, and saves everything which has been saved, and then basically logs me out. And then you press a button like Command Q, and you can exit the terminal. So these are all commands which have been written down as instructions. So I'm pressing only one button or two buttons on my keyboard, but that allows me to run a series of commands or instructions which have been coded into that shortcut or that type of instruction software, which allows us to execute these in a series of steps to get a particular output. And when you look at complex things like booting up a PC, you will see a lot of things happening in the background. And in about 35 seconds to 40 seconds, you get a DOS prompt or you get the Windows screen. And that is, again, a set of electronic instructions or instructions which has been written down as software, which are executed to check the memory is okay, the processor is okay, the power supply is okay, and everything checks okay, and then it starts to load the program, which is Windows, and that allows you to get to a screen wherein you're able to run things or applications, primarily on a computer system. Now, when we look at software, there are two different types that we define. There is something called a system software, and there is something called an application software. Now, this is quite evident from the fact that in order for you to look at working on the system, you need a base software which basically forms a platform and provides that platform to be able to install things on it to run. A simple example, when you buy a PC or you put together a PC, you install an operating system. An operating system is a system software because it allows all the hardware components to be brought together and work in unison to be able to give you a startup screen wherein you are able to then do other things. Now, when you install MS Office, when you install any sort of a software like WinZip or a browser or Skype for that sake, or any other software that you install on the system, system software becomes or is classified as application software. So when we look at the modern day computers today, you have something called the application store, both in Windows and also in the Mac. And what we do is, when we know that the basic system is installed or the operating system is installed, what it allows us to do is install a lot of other smaller softwares. So like on my Mac, I have the latest version of Mac OS Mojave, and that is the operating system or the system software. And once that software is installed, I'm able to go in and install some of the other softwares which are required, primarily to run, applications or do productive work. So if I don't have a Microsoft Word or a PowerPoint, I cannot have this presentation running, and that is where the differentiation comes between, the system and the application software. So system softwares are the softwares designed, coded, made, which work on the operations of the computer, and it facilitates, a lot of different type of resources to be coordinated together to give you an output. And an application side of software would primarily mean that these are installed on the system software on the operating system, and they then allow you to produce a specific output or work on a specific function or a program. So like you have Xbox, there is a particular software which is installed on it, though that is not a computer. But if you look at a console, they have some system software on it, and on top of it, you use the games. Like, for example, you play, Fortnite, or you play, for example, Call of Duty. These are all application softwares or games, as we classify them, which are running on the base system which Xbox or Microsoft has created. Similarly, you have an example of PS4, and the idea is to differentiate what is a system software and what is a application software. If we look at a bit more detail, what does the operating system do? The operating system, or the OS in short, allows the computer, different components of the computer, to interact with each other. So that processor runs in megaflops or petaflops in terms of its speed. You look at the graphics memory, which works at some megabytes per second. You have what is called the motherboard, which has some sort of a processor on it, which allows it to run instructions between different components at different speeds. Now, what controls all this? What creates the uniform platform which tells that if I have to give an instruction, using that, then all the people or all the components in this case fall in line. It's like an army general. When the army general gives a command, everybody falls in line to say, okay, this is what is being asked, we need to do this. Similarly, the operating system, in a way, looks at those set of commands, and these set of commands then allow some sort of a unison or an output to be produced by allocating, making the resources work together, and then creates a meaningful output. Now, when we look at operating systems, there are different types, as I mentioned earlier. There is Windows, there is Macintosh OS or Mac OS as we call it. You have the Unix and Linux. Now, there are other types of open operating systems as well, which are different variants of either Linux or Unix, but broadly classification would be the same, that there are three types of OSs, and these are the three different types. Microsoft, by clear margin, is the world leader in terms of market share. They have, I think, 69% or 70% of all hardware running Windows software. About 18 or 19% is Linux, and about 10 or 12% is when we look at Mac OS. Now, the operating system becomes sort of an intermediary between me as the user and the computer hardware. So it allows us to get some sort of a console or some sort of a kernel or command control, which allows us to input instructions in English that we understand, and that is then translated by the operating system into a series of instructions which works through all these components. So when we look at an operating system, they have different things in terms of the operating system. There is something, on the software side, which is primarily related to something called the the resource allocator, which manages and allocate resources, how much memory is to be used, which system or which application is running on the system, which allows utilization of memory. So these are things that you control. And sometimes what you see is if your computer system hangs, or if you're trying to work on something and the application is not responding, what you do is you do Control or Delete on Windows to forcefully exit that program. And similarly in Mac, we have an option to force quit applications, which allows resources to be reallocated. Now sometimes what we do is we need a command control or a kernel which allows us to run a lot of programs at one point in time. So an example of that which I showed earlier was a terminal. When I type a simple command like directory structure ls in Unix, it gives me a full directory structure of the hard drive or the flash drive which is installed. So the software side of things, if you look at, we need to understand what is an operating system, what are the different types, and how these have evolved over the years. So if you look at when the PCs came out, IBM, when they launched the first PC, they came out with something called an IBM operating system. Later on, that was termed as MS-DOS, because Microsoft worked on it and created a Microsoft disk operating system, because there was no memory in the computers. So what happened was they had to physically code a series of instructions to run the software, which is the system software, onto a disk. So in those days, you had the floppy drives or some sort of tape drives, and these were then inserted, interfaced with the machine to be able to run a series of instructions which the computer could or the hardware could take. And that is why it was called MS-DOS, because it stood for Microsoft Disk Operating System. Now this operating system was on a type of an external disk, but at some stage in the early 80s, when hard drives became popular, flash drives, when we say the disk drives became popular, the 3.5 inch, 5.5 inch, this operating system went onto a disk. So sometimes you have to insert a disk into the drive bay to run a series of instructions for it to load and for it to understand commands. Now in the 1990s, Microsoft introduced something called the graphics user interface when they brought out Windows 3.1, and that 3.1 for the first time had an interface which was more graphically orientated, and that allowed the mouse and keyboard to be used simultaneously. So the graphical user interface led to the creation of the mouse as we see it, or the input device that we use as mouse today, and that revolutionized the operating systems from then on. And then what we see is a gradual introduction of new versions of the software, which led to Windows 95, it led to Windows 98, Windows 2000. The smaller or shrink-wrapped version, which is of Windows software running on the thin clients, was called the Windows CE, or software which was actually running on some sort of consoles. And then over the years, in the last decade or so, we've seen Windows 7, Windows 8, and currently what we are using is Windows 10. Now, similarly, when we look at software which allowed multiple users or multiple operating systems to be used. So when we look at hard drives, and when we look at the early 2000s, what tended to happen is a lot of Macintosh users liked the hardware, but they did not like the Windows operating system. So they created an option wherein you could use parallels or use and install two different types of operating systems into a similar hard drive. So at the time of booting, you could press a button to say, I want to boot from Linux or Unix, or I want to boot Windows. And that allowed even multiple operating systems to be installed on the same computer. So sometimes programmers, when they wanted to code, they wanted to do most of the coding on Unix. So they had these two systems installed on the same hard drive. That allowed them to boot the machine into Unix to be able to code, create the program, and then to test the output, they used to boot the system into a graphical user interface or a Windows platform, which allowed them to test some of these applications. And as the systems have evolved, what we have seen is slowly and gradually, with the coming in of the graphical user interface, we saw multiprocessing becoming possible. That means you could use 2 or 3 different types of software or applications on the operating system. Like today, if I just show you an example, I'm using Word, PowerPoint, Excel. I can open a number of other software and they are able to run concurrently, is because the resource allocator, when we look at various components, in the operating system, things like, the control program, the kernel, allows the allocation of memory across different programs for it to be run. Now, graphical user interface allowed the multi-processing to happen. Like in the kernel, or MS-DOS prompt, when we had it earlier, if I give one command, only one can be executed. I don't have an option to open another window and run another command. So in that case, when GUI was introduced, or when Windows 3X or the Windows 3.1 was introduced, we had first time the ability to be able to do multitasking on computer systems, and that has then been slowly and gradually adopted into various operating systems. So you have the Linux and Unix also now having GUI, and some of these versions are available free. But when you look at Ubuntu, for example, one of the most popular Linux versions, it has a full graphical user interface like the Windows operating system and allows you to run multiple programs together, which means it led to the creation of something called application softwares, and application softwares required multitasking and multi-threading. Now, the multitasking term is quite simple. Multitasking means that you're able to run multiple programs at any given point in time when you are on the operating system. Multi-threading means that it allows different components to behave differently to different application or commands given to be able to run them concurrently. A simple example of that is what I will show you would be on the Mac, which is primarily a resource allocator. And the reason I would show that to you is because I think it will make it quite easy for you to understand. We have as of now different programs which are running, and these programs, when they're running, what we are able to see is that, as you can see in this, that there are so many different programs which are currently running. Now, the control of the operating system, which is the resource allocator and the key set of core instructions, allows the system software, which is the OS, to allocate memory. As you can see, it's dynamic; it's refreshing on its own. It allows it to allocate memory resources of the hardware to appropriately see how and basically to balance the load, and to appropriately see what application the user is using, and in order to make sure that it runs optimally and it runs fairly well, it allows it to take over the control, and that basically means multi-threading. So if I'm using PowerPoint at this moment, it is allocating more resources and memory to it, and because it knows that I'm using PowerPoint. But if I switch from PowerPoint to, say, the mail application, what you will see is that the mail side of application starts to use more usage, and this is something which is also being shown graphically here, in terms of multi-threading. So multi-threading essentially allows the operating system to control the different components of the hardware to run concurrently, but give differentiated outputs so that the programs are optimized and the output or the programs being used are responsive and are meeting the requirement of the user who's actually using them. Now, when we look at going from operating systems to application software, what we do see is that the rise of application software started to happen when we had the graphical user interface coming into the industry, so which is with the advent of Windows 3.1. And when you look at that, these application softwares were sitting on the operating system, were installed on the operating system as a base, and it allowed users to run different type of programs or functions to be able to create output or different type of, so different type of outputs required. An example of that is, the Microsoft Office suite, which has things like word processing, spreadsheets, you have database or Microsoft Access, you have presentation, which is PowerPoint, and then you have communication, which is email. Now, this software, which was created by Microsoft, sits and gets installed on the operating system and allows you to run various components to get different types of outputs. And this is where the advent of application software typically happens. So to give you an example, in the Mac, I've got different type of application software, as you can see, but they are all installed in the system, which is the Mac OS Mojave, and that allows the base, it makes available the base or the basic control mechanism for these application softwares to be installed. So if I want to make a mind map, if I want to do a flow chart, if I want to run a browser, they are then getting that base from the system's software, which is nothing but the operating system. Now, the application softwares, the use of the application softwares has grown over the years is because they have been created specifically to do a task. Now, a simple example of that would be when you use accounting software or when you use a movie software to play a movie on your Windows operating system or a Mac operating system. That software basically does exactly what it is asked to do. So it plays a video file or an animation file. And when you use software in terms of accounting, it creates outputs in terms of, balance sheet, ledgers, journals, and, profit and loss accounts and things like that. Now, the application softwares are very specific and they perform very specific functions. So you can't have an accounting software performing a function for making presentation or, a presentation software performing calculations. So these softwares were written specifically to do specific tasks, and that is why they are called application softwares. So if I look at the number of application softwares which I have installed, I have something like a number of them installed. So a typical example of that would be a browser. Rosetta Stone, which is primarily to do with the fact that I'm looking at, learning a language, which allows me to learn a language, a book software, which is a book reader. I have something which is a movie maker. I have a photo booth to take photos. I have a calendar software. Now, these are applications. A calendar software is primarily for calendaring. It only allows you to, have calendar applications. And that is something which, is specific to providing a function for doing calendaring app. That means you want to fix appointments, fix your schedule and things like that. Now, with the advent of applications, some of the applications over the years, what we saw is that in 1995, when Tim Berners-Lee actually created Internet and World Wide Web, or as it is called, came into being, what we do see is that a lot of these application softwares then started to be cloud-based. So it did not happen in 1995. But when we look at the dot-com bubble burst in the early 2000s, that led to the creation of a lot of different type of companies, and some of these companies started to create software or programs, or as we call them, applications which could run on the World Wide Web. So when you look at Facebook, for example, when you look at Dropbox, for example, these are application softwares which are currently running on the internet. So what I can do is I can straight away go into, say, for example, Dropbox, look at my look at my files folders, and this is something which I can access anywhere across any machine as long as I have access to the internet. So the advent of World Wide Web or the internet had a lot of advantages which allowed some of these applications to be created and run on the internet. That means they were running using the HTML code, Java, and some of the other programming languages which were created for the World Wide Web, which allow Flash, for example, which allow some of these applications to run on the browser. So if I look at YouTube, just as a simple example, on YouTube, is particularly, an application software, and this runs on the Chrome browser or any sort of browser. But when you get into YouTube, this is purely cloud-based, and this is primarily coming to you or running on the World Wide Web. And that is where you get to see that this is something, is an application software that you can have it installed on your operating system as an application or a widget, as we call it, or a program, but it also has the capability to run primarily directly from the internet. Is that okay?
Yeah.
Now, because applications today have, interface and are able to run on the internet, which is, on the World Wide Web, as we call it, they needed to have some differentiation in the compatibility, the construction, and the architecture for them to be able to run on the World Wide Web. Now, in order to have some of these applications run, there were different types of platforms which were created, and these platforms today we see are platforms like HTML, Java. We see platforms like the Flash, and these platforms now allow different types of output to be displayed on one screen. So if I look at now on the browser, what I do get to see is that from the YouTube channel, it is showing me stat images, playlists, it is showing me videos. But the moment I click on, say, one video, what you will see is that the video starts to play. You have audio video coming out of it. There are AdWords coming onto it. And this allows the host of different applications to run on the World Wide Web. Now, this means that there are applications which are interfacing with each other, and they have been programmed using, some sort of a very light programming language which allow data to be streamed across the internet or on the World Wide Web, and it allows users to, seamlessly view it depending on the connectivity that they have in certain locations. So when we look at this as a whole system, what we do get to see is that, sorry, let me just pause that. So what we do get to see as a system in terms of working is that the architecture of web applications, primarily are centered on the browser. That means if you did not have Internet Explorer or, Firefox, or, you look at Safari, some of the earlier versions which were very popular, there was something called the network communicator. If you remember Netscape, I don't know whether you recall the Netscape browser, that was the world's most popular browser until, up until, I would say, the Internet Explorer when it was introduced in the early 90s, and this used to be one of the most popular browsers which was used, on all the PCs, because this had much more functions than what the Internet Explorer in the early 1990s provided. But over the years, what has happened is all these applications that we get to see are primarily now centered around, running on the browser. And that is why it is important to understand when we talk about applications in particular, these applications can be run on the operating system, and these applications can also be run on something which is a platform called the web browser. And there are different types of web browsers which primarily are used by different people, and depending on their popularity type. But these browsers allow you to run a lot of different type of web applications. Now, having looked at that, what we also see, and I gave you a bit of an example earlier, was that when you look at web applications, there are web applications which are static. That means they are stationary, they display information, at any one given point in time, and they are not dynamic. That means until you refresh, you click, it does not change the content, and that application displayed is, quite static. So as you look at this one, this information might not change until I say press or, initiate another command, and it won't change or refresh. But there are applications which are dynamic. So when I look at YouTube video in particular, these applications, are taking the output of the browser to a different level because they have moving images, they are displaying video, they have the capability to, create sound, or, there's a bit of a voiceover. And these are full dynamic applications which are basically being, run on the browser. Now, some part of this can also be controlled, updated, modified, amended, and that can be done using something called a CMS. And this CMS is nothing but content management system. So when you look at a lot of websites, and to give you an example of, say, BBC News website. Now, these were created primarily because if I look at the news website, the news keeps changing on a daily basis. Now, there has to be a system wherein programmers or, coders at the end of it are able to change the news or, reflect new pieces of information on a daily basis. Now, this is done through something called the content management system. So there's a content management system which is being run in the background. A lot of people who understand applications and know how to design, develop, update websites using a CMS are able to do that. But all of that happens primarily based on, the web applications through the use of web browser. And this is where, you look at dynamic web applications coming in. Is that okay?
Yep.
Yeah. The other bit that you need to understand, this will be a bit technical, is that in order to understand how this happens, you need to know a CMS. You need to have a bit of grounding in terms of how you work on the CMS, certain commands. But most of these CMSs today, when you look at, content management systems, things like Joomla, you look at different types of CMSs, which are, you look at Joomla, you look at Drupal, you look at WordPress. WordPress is the world's most popular CMS or content management system, which basically runs about 85–86% of the world's website. And, there are different types, as you can see, but WordPress by far rules the roost because it's easy to operate, it's easy to use. It's something which is totally graphical user interface based. You can drag and drop and, have various tools and objects that you can use to create pages, modify pages or content, and that makes it easier for it to work. How does the CMS work? The CMSs are primarily based on working through, HTML, Java, queries, Java queries, Ajax, and also looking at Flash in some cases, and PHP. So that is the programming language which allows coders or programmers to basically create those dynamic applications. So when we look at that kind of a service, primarily in terms of web applications, we look at static type and we look at dynamic type. Now, apart from that, over the years, what we have seen is as the internet commerce has increased, the web applications have now included something called e-commerce. E-commerce basically means electronic commerce, or the ability for you to be able to transact and buy things on the internet like Amazon, eBay. They all involve a basic component, three-click mechanism, which means you go onto the software, you go on Amazon, you choose a product, you click on it, you add it to your basket, and then you click pay if you put your card details in, and it takes the payment, and it basically gives you a confirmation straight away that the product has been bought. Now, the web-based applications have evolved. So they started off as simple applications which were running on the browser, like dynamic static content, which were primarily websites. They became from HTML to Flash-based or PHP website, which meant that the content was becoming dynamic. You could play video, audio, all sorts of things on it. The third phase was when websites started to have e-commerce on them, and that e-commerce integration allowed basically the websites to, allowed the users to primarily use applications like Amazon, eBay, lots of other types, on the internet to buy goods, make payments, and obviously, to also having what you call the mobile side of applications. So if you look at the fourth type, we are talking about web portals. Portals then allow you to do everything. So you have a lot of chat portals, portals which allow you to send and receive emails, things like that. And that is the further, progression of how the applications are becoming more popular on the web. So people now do not look at installing everything on the PC. They have cloud-based applications, and these cloud-based applications typically are applications like Dropbox. You have Word, Excel, PowerPoint, Office 360 Suite, wherein you have the access to the internet. You're able to basically, pick them up and then, use them anywhere on any PC or any sort of device, which gives you connectivity to the internet. Now, in the last bit, I know some of these slides, are quite dynamic, but, they are self-explanatory. Just give me 1 second.
Sure.
So what then happened is, obviously, with the advent of mobile, this is also a smart device or a kind of a computer in your hand today because it runs most of the applications. As mobile became more popular in the early 2000s, they became more affordable, and they became complex devices where you could run multiple applications. With the advent of BlackBerry, you look at the Mac, the iOS, which got introduced in 2007, and the first iPhone allowed you to run applications like the email, the photograph, versions to listen to music, camera, and these 4 or 5 applications revolutionized the mobile side of applications, which then can be, installed, on that side. So when you look at, these applications in particular, what you do get to see is that this is also now a smart device, and this smart device allows you to basically look at, doing a lot of functions which are based through web-based applications, or as we call them, widgets. So some of these slides you will have to read through, and here the idea is primarily to get an overview and understanding of how the evolution of software, hardware has happened in the learning outcome 1, but in learning outcome 2, you're looking at understanding the evolution of software and the different type of operating systems, starting off with the system software or the OS, leading on to applications, leading on to World Wide Web or the internet, and then that World Wide Web allowing you to run applications which is on the browser, and then gradual introduction of applications or the advent of mobile or smartphones. So you have the mobile, in the 1990s when we had the Siemens S4, the Motorola D628, you had the Nokia 2210, but they were only primarily phones to be able to interface and have audio conversations and text messages. Before the phones, if you remember, we had something called pagers. I'm not too sure whether you know, but before the phones, we had pagers. So you could only page or text, and that was one-way communication. So from the system, you could page somebody, and they could receive a text, they could reply to you in a few set of words. After that, the mobile phones came in, and after that, the mobile phones came in, then you basically looked at, looking at basically the advent of smartphones, which came out in the early 2000s. And as the smartphones came out, the operating systems became more complex. You saw BlackBerry taking the lead, but later on, iPhone OS, came out, and it allowed multiple applications to be done together. And then we saw the advent of Android, and Android, which was created by Google. There were other operating systems like Symbian, which Nokia later bought, but they then allowed the applications to be run on mobile systems as well. So today, you have a smartphone, you can pretty much do everything on a smartphone as you do on a PC. You can even edit documents, edit software, and the example is that the Microsoft suite of applications, today is available on the phone, and you can actually even edit, make presentations, do documents, on the phone and email it to anyone in your circle or, anywhere in the world, because these applications then allow you to, run a full office or a full, suite of functions, which basically make you not just give you connectivity, but also allow you to send data, information, and different types of output to different people. Now, again, when you look at in mobiles, the introduction of touchscreens. So BlackBerry was mostly keyboard-based, but with the advent of the iPhone in 2007 August, you saw touchscreens becoming popular, and and then what we've seen is as the complexity of mobile phones has increased, as the evolution of mobile phones has happened, what we do get to see is other features being integrated. Now, in our lifetime, you can clearly say that we've seen that digital cameras are more or less being wiped out, because the camera function is now so good in the phones, the modern day phones that we buy, that you hardly use a digital camera. There are people who are using professional cameras, but most of the usage, if you look at around the world, is now primarily on the camera. You look at the TomToms and the navigation devices, satellite navigation, portable devices, which were from Nav1, TomTom, various different manufacturers. They have also had, their market tremendously declined. They're on the verge of extinction. So GPS or global positioning system is now more or less part of most of the smartphones. The building in of the gyrometer, which allows the mobile phone to determine at what height you are, what is the axis, or where you are in terms of location-based services. These are complex functions which have now come into the mobile phone, because the mobile phone has now the ability to be able to deal with these complex transactions, and these complex transactions, allow you to integrate a lot of different types of applications. So I can use my mobile phone to do put a route down and navigate using that to a particular destination. It can record voice. It allows you to take pictures. It knows at what height you are at. It knows, other applications like temperature, loads of other things which have come in. So as the evolution of devices have happened, and you see software side of applications evolving, we see different operating systems being created. The operating systems led to the creation of something called the application stores. The iOS store has more than 2 billion applications that you can download and buy in terms of apps, as we call them, rather than the short form, of applications as a word. And if you look at the Google Android, it has about 1.2 billion applications or apps, and you can download them on your phone, on your PC. So some of them, say for example, on my Mac, when I look at, they are predominantly apps, like Motive, that's an app. If I look at, something like News, which is an app. Now, these are not, applications designed primarily for, I would say, the PC or the Mac, but these are applications which are primarily designed for mobile devices, but they also have interface and connectivity when you use them across on, different platforms or different types of computer system. When you look at the WhatsApp version, I have a WhatsApp version of that installed on my Mac, but primarily it started off as a, chatting software or as a connectivity software on the mobile phones. But as the usage of that software has grown, there is a more WhatsApp version available for Windows, there's a WhatsApp available for Mac, and all types of different operating systems. So what we see in this particular section of Learning Outcome 2 is how computer software has evolved over the years, the different types of computer software in it, and then we classify them into operating system, application, web-based application, and then mobile applications, to understand, how the software side of things has changed the, world, and how software and different types of application. So when I say software, I say system software, which is OS, and the application side of software has allowed us to better control the hardware in order to drive more, operations in terms of multitasking, and that has led to the complexity of, applications that we can use currently on different types of platform. So this evolution is what you need to understand primarily in terms of, the learning outcome too. Is that okay?
Yes, that is.
Any questions on this so far?
No, not really. I don't think I have much questions on it.
So it is something that you can correlate to quite quickly because what smartphone do you use?
iPhone.
Okay, so you're on iPhone, you can understand some of the things that we've covered today, that how it runs at the App Store. It has an iOS on it, you have lots of applications on your phone, and it allows you to run a lot of different applications simultaneously. If you double tap on the home button, or if you have an iPhone X, if you flick it up, you see a lot of different applications running when you can close the applications to save battery time. And that goes to show that you have a good understanding in terms of, what a mobile phone operating system means, which is the iOS, how the application software is installed on it. And you go into the App Store, you look at a 3-step process of discovering something, finding an app, clicking on it, which is get, and then it gets installed if it's a free app. If not, then you pay for it, and it still gets installed on your, operating system. Correct?
So what if what if you want to buy something online? You have to click on it and then it directs you to a credit card payment, right?
That is correct. So if I look at a brief interface of how Amazon, for example, would work, if I look at the browser, I've got an Amazon account, I click on it, I put my username and password, you click on it, you go to the account, and what basically happens is you have an interface. Now, if I like something that I need to buy, I click on this device, as you can see, which is a tripod, I add it to my cart, I go to the checkout, and then basically what you can do is straight away enter this, and basically just buy it pretty much, and straight away you proceed to checkout, and this thing will take my payment from the card. I'll get an email which will say that your product has now been paid for, and as soon as the product is dispatched, you get an email. Now, the same kind of operating system or the ecosystem actually works on when you use the Amazon app on your iPhone or on any sort of a phone. And what tends to happen in that case is that you launch the application, you go into search option, you search the product, look for it in terms of description. If you're happy, you add it to your cart. Click one click. There is a system to buy that product by clicking on the shopping cart, and the payment gets charged, which is use of e-commerce. You get an instant email in milliseconds coming to you saying that thanks for buying this, and this product has now been paid for. And then a couple of minutes down the line, or depending on the product you've ordered, essentially, you get an email saying that your product is being dispatched. And at some stage, when the product is out for delivery, you can also track your delivery in terms of how many stops it is away, from your location or from your doorstep. So as the software has evolved and the connectivity in terms of World Wide Web has made location-based services possible, what this has made is that every step of the way you're able to track and have an experience wherein you know what is happening and you're totally connected with what you bought or when you are ordering something online. So the evolution, but all this is being currently done on a hardware. You cannot log on to something. You need a device. You need some sort of a device. It cannot be just thin air. When you watch movies like Minority Report, the Tom Cruise movie, he basically has a watch on his hand, and he touches a button. There's a holographic thing which comes up on board, and when you look at it, he's basically expanding the screens, making things or doing things. That is the future to come. But at this moment, you need still a device at this moment in time to be able to order things or buy things or do interactions, and that hardware device could be in different shape or forms. If you are on a desk, it could be a desktop computer. If you're moving about, it could be a tablet. If you're moving around, with a phone in your wallet and you have a smartphone, that could be a smartphone. But all this is hardware. There is a differentiation in terms of the hardware, but all this is different types of hardware. But all these different types of hardwares have different types of operating system or system software on it. So when I look at a PC, it has Windows or Mac or Linux or whatever. When I look at a tablet, it is running a shrink version of the operating system, which could be Windows 10. Like when you look at Microsoft Surface, When you look at the iPad, it is running a modified version of the iOS. And when you move to a mobile phone, you're running a modified version of the iOS to suit a smartphone. You look at a Windows phone, you look at an Android phone, they're all running system software. The hardware is either the phone, either the tablet, or the PC, or the server, whatever you call it. But when you run multiple programs on it, that is what we call applications. So if you launch a Safari, you launch a Chrome browser, you launch an Internet Explorer on your PC, you're running an application software which allows you to run further softwares or types of application to be able to interact using the World Wide Web. So it's all interconnected, as you can see, but depending on what device you're using, you still have the same classification of hardware, software, type of application, and the World Wide Web if you have connectivity via internet.
Yeah.
Is that okay?
That's fine.
Brilliant. So we'll end the session here today, and what I'm going to do is very briefly look at sending you let me put it this way, a presentation to look at addressing the assignment brief for this particular unit. Okay?
And this is recorded, right?
This is recorded, yes.
And what's his name? Samid will send me this entire recording.
Yeah, you will be able to see the recording coming to you on the email, yes, in a couple of minutes.
All right, cool.
Okay?
Yes.
Brilliant. So what I'm going to do now is basically look at, let me, if I just look at briefly, the assignment brief for this. Let's look at very briefly looking at the assignment brief. That's apparently on Moodle as well, but I'm going to pull it out locally from my machine because it's going to be a bit faster.
Yeah.
So if you go on to Moodle, get into the program, and go on to Computing and IT. When you are in Computing and IT, go to your course, which is level 4, and then you click this particular button, which is called 4.46 essay, or ending means sample assignment. You click on that and download it, and then you open them. That is the assignment brief that we are going to be attempting. So in this case, the assignment brief basically talks about a scenario. As you can see, it is giving you a bit of a scenario saying that you're working as an operations manager for Infinity Cars, which is a local car dealer, and they're looking at expanding their business. So what they want to be able to do is basically look at putting together, a different site which will have a requirement for computers, and you've been asked to put together that requirement for the new site. And these computers, they're giving you some hints in terms of they need to be networkable. That means you'll have to look at also allowing for networking. And then with this background, it is asking you to do 2 activities. Now, these 2 activities will cover the 2 learning outcomes, which are part and parcel of, your unit. So if I bring that up again, so if you see these 2 learning outcomes, learning outcome 1 and 2, here they are classified as activity 1 and activity 2. The activity 1 covers all the learning outcomes of learning outcome 1, 1.1 to 1.4. And the activity 2 covers all the assessment criteria of 2.1 to 2.4. And what, with this background, you have to look at is using the information which has been provided, you have to do some external research to design a documentation to put together something called, the information for Infinity Cars. So they're asking you to describe the components of computer system. So pick up the task, and what you're looking at defining in this is these are the things that you have to cover in this task. But at the end, in terms of looking at an example, that you're not doing it in an abstract form, they've given you a bit of a context or a scenario to say that, okay, as an operations manager for Infinity Cars working in the IT department, I'm going to put together a system which basically takes care of the business needs. And that business needs are that it should have software which will allow you to detail sales, stock, appointments, customers and suppliers. It will be able to calculate tax, service log, and maintenance log. So when you start talking about the computer system, you're talking about that we are going to put together, a computer system which will be of these types of components. There'll be 5 PCs in the office. One will be used for admin, one for reception, one for sales and booking, one for this, one for that, as a scenario, and then explain some of these systems briefly so that they are something that you're able to cover the indicative content which is given here. And then similarly go on to task 2. Because they've asked the systems to be networkable, that means you have to put together some sort of a small area network type of talk about the different types of network, which could be primarily LAN, MAN, WAN that we've spoken, but in that just use a basic infrastructure, which is to say that a local area network would be required to be put together, and that local area network will be a LAN, and in that use a diagram to basically show the topology of what you're trying to make, and that will give you some example in terms of covering the network part of things. I'm going to show you something which is looking at handout. Okay. Talking 4.46. So I did show you a particular assignment, which was primarily looking at, in terms of, I'm just going to try and pull this out. So this is what the learners developed, and in terms of the network, because he did not do this in a bit more detail, so that the task 2 talks about network infrastructure. So you've basically shown a number of computers being connected using network, and then you explain the different types of hardware which is required to create actually that network, and that will help you to cover the task up. Is that okay?
Yes.
So I think at some stage, what I would suggest, Rishwin, to you is at some stage, what you have to do is just start looking at the assignment brief, and in the assignment brief, start putting the tasks down. What is required to be put in these tasks has to be taken from here, which is the indicative content, and that is what we've covered in the PowerPoint slides. I will send you a sample today for you to look at, so that when you do your first assignment, you have an exemplar with you to try and refer to how it is being done. Because this is maybe a bit new to you, you have to do a bit of writing, and how you do that, how you structure it into a format in terms of the assignment, how you address the task. I'm going to send you a sampler for you to look at, and extracts from the sampler for you to be able to understand how this is done. And that is how you're going to develop this going further for some of the other units.
Okay. Yes.
So expect that to come from me in the next couple of minutes. Samit will send that across to you along with the copy of the recording, because it takes about half an hour for it to be processed. And then once it's available, he'll send you the assignment, discussion, presentation, and also a sampler along with the recording.
Okay. All right.
Any questions that you have, please fire away on email, and I'll come back to you pretty much straight away.
Okay. All right.
Okay. And you'll also receive invites from Samit, for the next sessions for the next unit.